one of the first major mathematician astronomer from the ancient India who discovered relativity of motion almost 1400 years before Albert Einstein had discovered it. He discovered the relativity of motion in the form of Sanskrit shlok. He was the one who gave the idea of the first digit 0 in the Hindu-Arabic numerical system. Yes, you guessed that right. I am talking about Aryabhata. So let's get started. Aryabhata was first of the major mathematician astronomers from the classical age of Indian mathematics and Indian astronomy. His works include the Aryabhata and the Arya Siddhant. For his explicit mention of relativity of motion, he also qualifies as a major early physicist. Aryabhata was born in 476 CE. He called himself a native of Kusampur or Patliputra, but it is unclear because certain text mentions that his origin was from Kerala. But it is fairly certain that at some point he went to Kusampur for advanced studies and lived there for some time. Aryabhata was the head of University of Nalanda in Patliputra at that time, which had an astronomical observatory too. Aryabhata is also reputed to have set up an observatory at the Sun Temple in Tarigana, Bihar. His major work, Aryabhata, a compendium of mathematics and astronomy, was extensively referred to in the Indian mathematical literature and contains arithmetic, algebra, plane trigonometry, and spherical trigonometry. It also contains continued fractions and quadratic equations, sum of power series, and table of signs. It was remarkable of him to discover these postulates at that time. His other book, Arya Siddhant, is a lost work. It is not available now. It is based on the astronomical computations, and we know this through the writing of Aryabhata's contemporary Varamir and later mathematicians and commentators, including Brahmagupta and Bhaskara I. This work appears to be based on the older Surya Siddhant and uses the midnight day reckoning. Midnight day reckoning refers to the length of one solar day as opposed to sunrise in Aryabhata. Aryabhata mentions that the beginning of the day is to be reckoned from midnight at Lanka and also that the day begins from sunrise at Lanka. They are two opposing statements. Lanka is an abstraction standing for a point on the equator as of the same longitude as Ujjain is located, and this would fall somewhere around in the Indian Ocean. The Arya Siddhant also contained a description of several astronomical instruments. For example, the shadow instrument and the Shanku Yantra, and water clocks of at least two types, bow-shaped and cylindrical. Direct details of Aryabhata's work are known only from the Aryabhata. The name Aryabhata was not given by Aryabhata himself but due to later commentators. There are 108 verses in the text and 13 introductory verses. It is written in typical sutra literature in which each line has a complex meaning. The Aryabhata is divided into 4 chapters. The Aryabhata presented a number of innovations in mathematics and astronomy in verse form which were influential for many centuries. The Aryabhata explains relativity of motion as just as a man in a boat moving forward sees the stationary objects on the shore as moving backwards, just so are the stationary stars seen by the people on earth as moving exactly towards the west. Aryabhata worked on the approximation for pi and may have come to the conclusion that pi is irrational. In the second part of the Aryabhata, he writes a formula according to which pi's value was 3.1416 and it is correct to 5 significant places. It is speculated that Aryabhata used the word asan to mean that the value is irrational. Aryabhata also gives the area of triangle in the Aryabhata. He has also given algorithms which became the standard method for solving Diophantine equations in Indian mathematics. He also has stated that the earth rotates on its own axis and also that it revolves around the sun. Everyone opposed this statement because earlier it was believed that the earth was the center of the universe. He had also come to the conclusion that the moon had no shine of its own but it shone due to the reflected rays from the sun. On basis of this, Aryabhata came to another conclusion. Aryabhata explained solar and lunar eclipses scientifically instead of the prevalent cosmogony in which eclipses were caused by Rahu and Ketu. He explained that they take place due to the shadow of moon falling on earth. Aryabhata also calculated the sidereal rotation as 23 hours 56 minutes and 4.1 seconds, which is approximately the same as known today. The capability of calculating the length of year with such precision at that time is incredible. Now, I am going to tell you about a very interesting fact that you wouldn't have heard before. And the fact is that some shlokas in the Vedas mentioned about the presence of water on the moon. And astronomy experts in ancient India like Aryabhata knew about gravitational force much before Isaac Newton. 1400 years before Newton had discovered gravitational force, Aryabhata knew about that. I'm not making up things. Listen to this audio clip from one of the scientists in ISRO.
Of course, we are really proud that Aryabhata and Bhaskara, they have done extensive work on the planetary motions and all. This is the exploration of the outer world was one of the challenging fields, and we were really amazed by the type of knowledge which these people have accumulated and the type of computations and methodology for prediction and so on. And if you ask me, even for the moon mission what we have done, the Chandrayaan, Aryabhata's the basic equations holds, but we have only translated into the computer programs and utilized the rocket power and so on, and even the gravitational fields which existed and so on. The Newton found this almost about 1500 years later, but at this time itself this knowledge was existing in Bharat. So this is something which all of us can be proud of.
Copernican heliocentrism is the name given to the astronomical model developed by Nicholas Copernicus, and it was published in 1543. Heliocentrism is the astronomical model in which the Earth and planets revolve around the Sun at the center of the solar system. And the same thing was proven by Aryabhata, which we have already discussed. Calendar calculations devised by Aryabhata and his followers have been in continuous use in India for the practical purpose of fixing the Hindu calendar. Aryabhata was also the name given to the India's first satellite, named after the famous Indian astronomer of the same name. It was launched on 19 April 1975. Alas, this great mathematician died in 550 CE when he was 74 years old.